Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, everyone. My name is Muhammad Hilman bin Muhammad Radzi, and my metric number is 1210600. And this is the course of SKJ 2053 Discrete Mathematics, which is the assignment 2, which is relations. So in this presentation, I'm going to be presenting about relations, and as you can see here, I'm going to talk about a little bit about what is relations, the introduction of relations basically, and then we're moving on to the example of the relations. There is supposed to be in this presentation, I'm going to present about the basic example about relations, and then we're going to talk about how the application of relations in a real life situation, and then next is conclusion of the relations. So moving on to the next slide, which is the introduction of relations. So what is relations? So basically in discrete mathematics, a relation specifies the link between two distinct collections of information. For example, there is a collection of one information, for example, number 1, number 2, and number 3. And then the second collection of information is number 3, number 4, number 5, number 6. Okay, so when these two sets are studied, their relationship is established if there is a link between the components of two or more non-empty sets. So basically, a relation is something that if there is one collection of information and there is one more collection of information, so what is the relationship between those two collection of information? So basically I write this at the right side, which is the set of ordered pairs that satisfy a relationship. We're going to be studying the example next in this slide. Moving on to the example. So I wrote this relations set of ordered pairs that satisfy a relationship. So let's understand this using an example of two sets. We have two sets W and Z, where set W has 2 elements and set Z has 4 elements. So in set of W, we have 2 and 4, whereas set Z, we have 10, 20, and 35. So we first take the Cartesian product of the two sets. So as you can see here, we use an arrow diagram for the Cartesian product of set W and Z. So W cross Z is the set of the following ordered pairs. So it's 2 paired with each of these 3, and then 4 paired with each of these 3. We get 6 ordered pairs of the form of W, comma Z, where every W belongs to set W and every Z belongs to set Z. That's how it can be written in the set builder form. So now let's introduce a relation R. So relation R gives us a set of all ordered pairs W, Z that satisfies relation R. So it could be any relation. So now suppose we introduce a relation R dash here. So such that Z is a multiple of W. So we can say that relations R dash give us a set of all ordered pairs W, Z, where Z is the multiple of W. Every ordered pair in the set R dash satisfy the relation R dash. This is the set of builder method to represent R dash. Please note that Z has to be a multiple of W here. So now let's choose the ordered pairs from a Cartesian product W cross Z here. So notice that 10 is the multiple of 2, and then 20 is the multiple of 2, and also 20 is the multiple of 4. So we get the ordered pairs 2, 10, 2, 20, and 4, 20, such that every ordered pairs satisfies the relation R, where Z is a multiple of W. So this is the roster method, represents set R dash. So roster here means list. Can also we can also represent this using an arrow diagram here. We can draw an arrow for every ordered pair in set R dash. So we can draw one arrow for 2, 10, one arrow for 2, 20, and one arrow for 4, 20. Moving on to the next slide. So moving on to the real life example, we will try to use an example of buy drinks in a vending machine. So many of you didn't know, but we do use relations in real life situations such as buying drinks in the vending machine. So same usage as the previous example. Using two sets, we have set P and set Q, where set P has elements 2 ringgit and 5 ringgit, which is the money that you can use to buy the drinks. And then set Q has the elements T, Coke, and Nescafe, which is the drinks available in the machine. So we first take the Cartesian product of the two sets. Let's use an arrow diagram here for the Cartesian product of set P and Q. So P cross Q is the set of the following ordered pairs. We get 6 ordered pairs of the form of P, comma Q, where every P belongs to set P and every Q belongs to set Q. So that's how it can be written in the set builder form. Now moving on to the relation that we will use. So relation R gives us the set of all ordered pairs P, comma Q that satisfies relation. It could be any relation, but as you can see, we use the relation R dash here. Q is drinks that you can buy with 2 ringgit. So we can see that relation R dash here gives us set of all ordered pairs P, comma Q, where Q is drinks that you can buy with 2 ringgit, where every P belongs to set P and every Q belongs to set Q. So this is a set builder method to represent R dash. So please note that every Q here is drinks that you can buy with 2 ringgit. So now let's choose the ordered pairs from a Cartesian product P cross Q that satisfy the relation here. So let's look at the ordered pairs here. So as you can see, notice that T is a drink that can be bought with 2 ringgit, and also Coke is also a drink that can be bought using 2 ringgit. So, but Nescafe is usually very expensive in vending machine. Could probably be like 5 ringgit or so. So we get the ordered pairs 2, comma T and 2, comma Coke, such that every ordered pairs satisfies the relation R. It's a drink that you can buy with 2 ringgit. So this is the roster method to represent set R dash. So roster here means list. So R dash can also represent it using an arrow diagram here. We can draw an arrow for every ordered pair in set R dash. So we can draw one arrow for 2 ringgit, comma T, and another arrow for the 2 ringgit, comma Coke. So that is all. So the last bit is the conclusion. So in a nutshell, relation and functions are very interesting in our daily life if we do realize it. As you can see as the previous example, the real life example, even vending machines had to be a part of the relation that we just learned. So moving on, let's say this entire circle represents the set of elements in the Cartesian product P cross Q. In that case, set R dash will be a part of it. So we can say that set R dash is a subset of Cartesian product P cross Q. So that is all from me. Thank you. I'm Hilman from Radzi. Matric number 1210600. Signing off. I hope you can understand a little bit more about relation based on the examples that I've given. Thank you.